I am currently doing work through the Buddhism and AI initiative, which is something that I kicked up. I see Alex Sarkissian here in the channel as well. He's on my team. There's some other folks from AI and Faith who are working on this project with me. And this all got started largely through AI and Faith. When I joined as a member, there were, I think, two other Buddhists in the network. There might be five now, so still a small but hopefully growing part of the network. And it was Alex, Peter, and myself that kicked this off. Before that, I was the COO of an AI safety company in London called Conjecture, which did a lot of work around risk from AI, and particularly super advanced and powerful AI. And before that, I got my start in AI, doing some research around large language models as simulators. That's something that I'll talk about a bit later. But for now, the relevant thing is just been involved in the space for a little while and have really been an insider to some of these conversations around superintelligence. And so if I'm beating the drum on, hey, there's a bunch of people taking this seriously who are not just using it for commercial hype, that's why I've been around them. So what we're going to cover today, we're going to start with the history of the modern AGI movement, talking about sort of where this ideology came from. Then we're going to talk about the technical question, which is, okay, sure, some people believe in this, but is it really possible? Then we're going to talk about safety responses, which is depending on how powerful you think the tech will be, what type of safety do you think is necessary? And finally, we're going to cover spiritual responses. And that will all explain, why I'm doing the Buddhism and AI initiative, and I'm sure it parallels with why many of you are engaged in these conversations yourselves. So, the history of AI is often told as the history of increasing capabilities. These lines go up. They show that AI capabilities are meeting or exceeding human performance. And the story is that AI has gotten better at games and more subjects and is catching up to human level. This is not the history that we're going to be talking about today. Instead, we're going to talk about the ideological history, where this idea of artificial general intelligence came from and how it's gone from a niche to a research to a competitive to a commercial to a political and now a geopolitical subject. I'm not going to spend too much time defining superintelligence because it looks like a lot of you are familiar with the concept. But roughly, we're talking about systems that are general purpose, so can do pretty much any task that a human can do, don't require human supervision. This is the artificial general intelligence portion of this, and could potentially become so intelligent that we're not really able to understand what's going on with them. This requires a bit of hyperbole, but this is a real example taken from something called shock levels. So shock levels, roughly, I'll point to this in a sec. The group of people who originally started taking AGI seriously wrote about different levels of thinking about science fiction futures. And so at the basic level, there's what most people know about technology. And then that goes up to stuff like novelty seekers and scientists. And then at SL2, we get weird things like medical immortality, interplanetary exploration. At higher shock levels, SL3 and 4, we start talking about things that are borderline spiritual science fiction, talking about turning the whole entire universe into computation and then using that to make programs that simulate other universes. And so all of this might seem highly extreme, but it's also important to anchor what people mean in superintelligence to some of these extreme levels. Because some insiders use that word and they're really talking about things that can transform the galaxy, and others use it simply to mean the product that OpenAI is building. So let's talk about where this came from, because indeed these concepts did come from science fiction. The birth of the AI field was very much wrapped in this notion of maybe we could replicate human intelligence with machinery. But those ideas took us to the point of thinking about automating certain parts of the economy and not to some of these concepts around superintelligence. That came later in the 60s through the 90s, where a bunch of science fiction authors like Vernor Vinge and scientists like I.J. Good popularized concepts of the intelligence explosion and the singularity. The singularity is the concept of a point in time where technological progress becomes so fast that humans are no longer in control of the future, and that it's sort of a rollout of just increasingly sophisticated science and tech covering all of the future. This sounds pretty crazy, and it is. And in the 1990s, late 1990s to early 2000s, people started taking this more seriously. So an organization, well, it was more of a email newsletter early forum called SL4, wrote this shock levels thing that I shared on the last slide. And this is written by Eliezer Yudkowsky himself. He says, the interesting thing about shock levels is it's not about believing them, it's about feeling comfortable with it. When I first ran across the idea of the singularity, I knew immediately that Werner Vinge was perfectly right. I felt my entire ethical system restructuring over the course of about 5 seconds. 5 seconds to believe, 3 years to acceptance. Why is this important? Well, this was the first time that there were a group of people that said, maybe these aren't just science fiction concepts. Maybe these are ethically important concepts and technically important concepts that we should consider for the future of our own lifetimes. Interestingly, this is also predicating the history of the first AGI company, which is DeepMind. So Yudkowsky, the person himself that wrote that, was the one who connected Peter Thiel to Demis Hassabis and Shane Legg when they were originally seeking funding for DeepMind. Shane Legg was a member of this SL4 forum, and so these early participants in the race to AGI were well informed about these science fiction and semi-religious stakes of the AI movement. This is also where the competition from other AI companies came from. In 2014, DeepMind was bought out by Google. Elon Musk at the time was invested in DeepMind and he lost his stake as part of this. And in those early days of Sam Altman and Elon Musk coming together to form OpenAI, they had conversations like the one on the right here, where Musk writes, several hundred million dollars won't be enough. This project of AGI needs billions per year, immediately or forget it. Unfortunately, humanity's future is in the hands of blank, probably Demis. Which is to say that even in the private conversations of the folks working behind the scenes on these companies, there was this existential consideration. The entire future of humanity was what was debated as part of this AI story. Anthropic split off from OpenAI for similar reasons. And as we'll see, Dario, who's the CEO of Anthropic, uses language like this all the time. In fact, he's one of the most public about his views on this level of risk. XAI, Elon's latest thing, back in the race for similar purposes. And in 2023, you have ChatGPT come out, and the story changes, which is that prior to this, this was largely a niche research interest, and now the money starts coming in. And so commercial interests explode after 2023, and each of these smaller AI companies begins to pair with larger big tech companies. OpenAI with Microsoft, Anthropic first with AWS, but now with Google as well, DeepMind with Google, X is kind of Elon's own empire, Meta enters the race. And these five players here are the main Western players you see that are competing to build powerful AI. And so ideologically, all of them have their roots in this competition to build AGI and superintelligence. In 2024, this starts to become a political interest and political matter, which is to say that nations start thinking, wow, AI is really important. What do we do about it? The UK forms the first AI Safety Institute, and the AI Safety Institute is filled with people who also believe this story. In fact, its kind of CEO came from OpenAI and was one of the lead safety advocates there. And now we have things like America's AI Action Plan, where the first sentence says, the United States is in a race to achieve global dominance in artificial intelligence. Now, I'm not saying every person behind the scenes believes this, but what I'm saying is that there is an intellectual history of thinking about AI as having such significant stakes that the person that controls this technology will be able to decide the future of humanity. Whether that is technically true or not is not the point of this history. It's to point at the addictive ideology, the intense idea of power behind AI that becomes really quite a significant motivation for many of the people who are working on this and building it now. So, this is to say, people make plans based on the world that they think they're living in. Action and ideology are related. In this case, what we're looking at is that companies race to AGI based on the belief that it's technically feasible. And here we can see some of the manifestos from various leaders of the companies that write about this, with Dario, who I mentioned before as head of Anthropic, saying, Powerful AI could be summarized as a country of geniuses in a data center. This tweet here from Rune, I think, is telling. Rune is an employee at OpenAI who writes a lot on Twitter. And he says, right now is the time where the takeoff looks most rapid to insiders. We don't program anymore, we just yell at AI agents. But may look slow to everyone else as the chatbot medium saturates. What he means is that there's a group of insiders who hold these views about takeoff, the AI sort of exploding in capabilities, but not everyone is on the same wavelength about that. So you could be on the outside and think, well, GPT-5 wasn't that much better than GPT-4, but to insiders, this is the period where AI is really speeding up. So what have we covered so far? First, there's a long history to the AGI ideology. Started with science fiction, then started to get taken seriously by a niche group of people, and is now behind the scenes within a lot of major AI organizations and even government conversations. We're also looking at motivation. Superintelligence is a real North Star for many of these companies. And while commercial interests have become involved since 2023 in very significant ways, it's not to say that it's purely a commercial intent that's happening here. There's a general sort of drive for the type of power that AI might be able to provide. And finally, I'm claiming that this gives us predictive power. That if you see the AI story through this superintelligence narrative, you get a bit of a clearer idea about what's going on technically and the direction that people are taking all of this in the labs. But we don't know if AGI is technically feasible. And so the question is, will all these efforts actually work to do what the companies want? That's what we're going to cover in the next section, which is there a technical barrier that is too difficult? If you have this as the North Star and you've got billions of dollars and entire nations that have the backing of trying to build this project, it's not really a question of if we want to build it, it's a question of is it too hard? And so we're going to be looking at that now. So first, let's do a bit of a deep dive into how AI models work now. This might be familiar to some of you already, but the core thing that I want to emphasize is that foundation models, this central part of the AI ecosystem, we've built on top of it to create increasingly powerful technologies. And at the upside, the sort of total capabilities of a system like this can still go much further than what we're seeing today. So on the screen here, we have an overview of the AI ecosystem, which is to say that these foundation models require some inputs. They need data, oceans of it, everything on the internet, all the books ever written, every text message we've ever sent, all of that is getting fed into these models. And it needs to be trained, which is that physically, AI is instantiated in warehouses of these chips, which are small computers that can run mathematical operations really quickly. So there is a physical home of all of these large AI systems. When we train these models, we feed in all of the data and we eventually get the models to be able to predict text. I'll talk a bit about how that technically works in a sec, but roughly we can think about these models as baking in the oven for a while and then coming out and being a bit of a brain in a vat. It does what we ask it, but it's very agnostic. It doesn't have a strong persona or chat-like identity to itself. That comes later. These foundation models can then be used in workflows and agent systems. And we're going to talk about how this works in a minute. So, what is a base model? This is the thing that comes out of the oven after you've trained the system. A base model is different from the type of technology that you might interact with now. You might talk with ChatGPT, and whenever you ask it something, it responds to you or it follows your instructions. Not what a base model does. And now we've got more complicated systems, like reasoning models and agent and multi-agent systems. We're going to talk in a sec about how all of these work and how they're technically linked. But right now we're zooming in on base models. These are the kind of original prototypical thing in the AI stack. When you ask a base model a question, or when you tell it to do something, it continues your text. It doesn't respond. So if I say, tell me a story, it might continue about the time when you. If I give it the first 50 words of Harry Potter, it might give me the 51st word. Here in the next token prediction section, it doesn't know what the right word is. And so it's guessing whether Mr. Dursley has a very large beard or a mustache or a hat. It's simply predicting what it thinks the next possible word could be. To get even deeper about what's happening here, What we do is we take in an input, which is a bunch of text. We then transform it through an embedding layer into a bunch of math. In the center of these transformer blocks, lots of math happens. And then we use another function to turn that math back into English language. And this goes in a cycle over and over and over. I said that we train these models to predict text. So how do we do that? Well, let's say we wanted to get it to predict the 51st word of Harry Potter. One of the things we can do with all of our training data is we can cut it up into slices. We can take the first 50 words and then show it, here's the 51st word. We can take the second word through the 51st word and say, what's the 52nd word? So we can take all these slices and show it examples, and then the language model learns to predict grammar and semantics and meaning and even physics based on this. Because it turns out most of the time that text has been written, when you drop an apple, the apple falls. And so this ability to do next token prediction, even though we're just guessing the next word, enables models to have large language capabilities. They can do things vastly beyond copying their text towards being able to generate and write new text. So this is the generation process. We can give it 100 new words, a whole paragraph, now papers. It turns it into math. It uses all of those patterns it's learned, and then it turns it back into English language. What's interesting about this setup is that it's not just language that this works with. We can do this with images, we can do it with video, we can do it with sound, we can do it with weather data. As long as we can transform something into the math space through an embedding model, we can use the same mathematical operations. And what this is pointing at is it's pointing at something more like concepts than math, which is that it's not just the words. It's that when I say blue, blue for us is associated with the color of the sky, the color of my water bottle, the feeling of sadness. These various associations with a single word are the same thing that happens within an AI model. And that broad semantic understanding is really the deep thing that's going on with these models. It's not just copying text, it's learning a semantic definition. That becomes the foundation of this entire ecosystem of products. And so from the base model, we now have chat models, which are models that talk back to us and respond. The way that we get these is that we take this very agnostic thing that just predicts texts and we give it more examples of what a chat conversation looks like and what instruction following looks like. And roughly, we give it so many examples that now when we ask it to predict text, it always predicts that it's supposed to respond, and it always predicts that it's supposed to follow instructions. And so if we say, tell me a story, it'll say once upon a time. It'll respond. It won't just continue the text. This is also where we build in ethics for the most part. We give it a bunch of examples of what ethical conduct might look like, and so now it predicts things that are more ethical. One of the things that this does suggest, though, is that safety is not built in from the start. What's built in from the start is broad capabilities. And then from those capabilities, we narrow the model down to the parts that we think are safe or the parts that could respond to us. And so in the total space of what the AI model knows, it's dangerous. It's agnostic. It can write a speech from Hitler just as well as it can write a love poem. That's why jailbreaking happens. It's because the fundamental part of the system itself does everything. We kind of make it narrower to do the stuff we want, and jailbreaking reveals those original capabilities. We now have reasoning models as well. Reasoning models take the ability for a language model to generate multiple answers, and we roughly optimize the models to give us the best answer. So normally, we ask a question and it gives an output, input, output. But there's something called chain of thought, where what we can do is we can get the model to think a few steps. So if I ask a math question and I say, what's 4 plus 6? The original model might say 11. But you can train a model to say, if I add 4 and 6 together, I have to get the sum of 4 and 6. To do that, I will. And all of this extra thinking starts to condition the model towards sharing a more correct answer. And so reasoning models abuse this. Well, maybe they train on this to create more powerful systems over time. Let's say I produce 3 different answers. Let's say I produce 1,000,000 different answers. And then from that, I search for the outcomes that produce the best results. This is how reasoning models have become so powerful in the last 6 months to a year, is that they've taken all of the original inputs, used those to generate many candidate answers, and then retrained the models on the best answers. So you start to bake a logic into the model, which is here's how to answer a question in a more sophisticated way using a better chain of thought. The reason this is really important is because it helps show us how AI models have gotten good enough to do things like win the Math Olympiad gold. The way they've done this is that imagine a very, very smart person was guessing the answer to the Math Olympiad by making statements that sounded roughly correct. They have no idea how to do math, but they're just stating millions of things. We could guess that maybe within all of those guesses that they've thrown out, the right answer exists. And the same thing is true for language models. If you imagine that every single token that gets rolled out generates sort of a tree of many possible answers, getting to the right answer is more about selecting which branch of that tree arrives at the accurate answer than it is thinking from first principles. We've been able to get models to do exactly that and take it to really far capabilities. And this is not just proving test taking scores, because here's a thing I found yesterday where Terence Tao, largely regarded as the brightest mathematician alive, is talking about using AI to write code to help him with math proofs in a way where truly the most elite intellectual skills that humans are working on right now, AI is competing with. And that's all because we've built up on top of these very agnostic base models. There's great potential in there to pull out strands of true wisdom or true intelligence. I'll get technical with a word like wisdom later with this group. So we can do even more than that. On top of the back of this, we can build agent and multi-agent systems, which is that we can get them to answer a lot of great questions, and we can also teach them to use tools. And so here's a video from Gemini 2.5, which came out earlier this week, I think, showing computer use in an AI system. And the reason this is meaningful is because it's showing the combination of multimodal capabilities that we talked about. We're looking at a screenshot, so image. We're looking at taking that screenshot and thinking about it, so language. We're looking at moving a mouse over the screen and messing with inputs, so actions. And all of this happening in a cycle over and over. And so off the base of these foundation models, which were originally just trained to predict text, we're creating systems that are able to navigate computers for us and do manual tasks. And this is really just the start. We can imagine that this could go much further. So why build AI in the first place? Well, we talked about the ideology, about whether you're motivated to build superintelligence or if you're trying to use AI for commercial purposes. And I would conjecture that the build direction that we're seeing from these companies is not to apply AI to solving world issues. If we were simply building AI to solve world issues, we wouldn't have a core motivation within all the AI companies just to build more and more powerful AI. At some point, you would expect that the cost, the billions of dollars of training more powerful systems, would not outweigh the need to apply these systems in relatively meaningful, wholesome ways, like to healthcare and to scientific discovery. This might be an overgeneralization, but the point I'm trying to make here is that thinking that the primary motivation of the companies is to train more and more powerful AI is helpful in predicting the technical roadmap that this is all going down. And so if we go back to that question of how do you get from artificial narrow intelligence that we have today to general intelligence and superintelligence, there's a few things that AI might need in order to take the next step and become capable without human oversight or to become extremely powerful. This is a list I made up, so take it with a grain of salt, but there's some things that we know AI already has now. We've talked about multimodality, the context to be able to work with the computer screen and understand what's going on there, domain expertise, mathematics, coding, and optimization, which is taking these systems and tuning them for specific purposes. To get to general intelligence, these systems need to become more agentic. They need to work for longer periods of time without breaking down. They need to be able to correct their errors, and their information needs to be grounded in the real world. I said earlier, maybe from all the patterns in language, you could impute some sort of physics on top of that, but it's not really understanding a physical world. And so that's a roadblock that hasn't been crossed yet. Online learning, we'll talk about in a sec, but it's about learning things really rapidly, much quicker than the big data approach that we're seeing now. And when we talk about artificial superintelligence, the key thing here is really this last point about automated science. This is the ability for a mind or a technical system to navigate in an environment in a way where it knows what it's learning, situational awareness. It's able to simulate and make hypotheticals. So it doesn't need the real world to interact with. It can interact through digital domains, so it can learn much quicker. And the epistemology overall to say, here's what I'm doing and why, and I'm going to the next step for this reason, and I've learned this, and so it updates my information in this kind of way. This is not an exhaustive list, but it's some of the type of things that you might think about for a system that for why our systems are currently breaking down, so that they don't have these capabilities. And so if the point of, hey, people want to build super intelligence is kind of behind the scenes here, we might expect that people are working on these, and they are. So on agency, what we see is AI systems becoming increasingly capable of tasks over long periods of time. What this chart is showing is that systems are now able to complete 2 hour long coding tasks with a 50% success rate. This is now an already outdated chart. I believe some of the latest OpenAI models can operate for up to 7 hours without human oversight. In terms of online learning, I mentioned this because it's one of the things that I worked at Conjecture, where we were looking to teach models things with a single example or fewer than 5 examples. LoRa is a type of fine-tuning that allows people to change just one part of the model. And so they can use fewer examples and less compute to try to update these models. This happened a while ago, and now people are working on even more cutting-edge methods to try to teach models things very quickly. Error correction happening, rapid improvements here. This is a recent paper from OpenAI that shows that getting models to start to admit when they don't know stuff lowers hallucination rates significantly. Not a huge, like, this doesn't change the game entirely, but clearly this is an area of interest that people are continuing to knock on the door of. And finally, potentially most meaningfully here is world modeling. And so I'm not sure if my audio is connected on this, and so I might have to narrativize on top of this, but I can see Gretchen and Greg right now. So if one of you can give me a thumbs up if this is playing audio, I'll let it talk. If not, I'll explain what's going on here.
What you're seeing are not games or videos.
So I'll explain this.
They're worlds.
So what you're seeing.
Each one of these is an interactive.
Oh, you can hear the video audio?
A new frontier for world models. With Genie 3, you can use natural language to generate a variety of worlds and explore them interactively, all with a single text prompt. Let's see what it's like to spend some time in a world. Genie 3 has real-time interactivity, meaning that the environment reacts to your movements and actions. You're not walking through a pre-built simulation. Everything you see here is being generated live as you explore it. And Genie 3 has world memory. That's why environments like this one stay consistent. World memory even carries.
So I'll pause there. But roughly what this is demonstrating is a lot of the things that we just talked about. It's demonstrating simulation. It's demonstrating real modeling. It's demonstrating object permanence. It's demonstrating physics. These are all things that previous models have been ungrounded in, and new advances in roughly getting AI to generate video games that have some of these more world-like properties built in enables models to learn from. So all of these areas about making AI more capable, more agentic, able to operate over longer periods of time, that's all happening and within line of sight for many of these companies. Finally, automated science. Here's Dario Amodei, the CEO of Anthropic, saying, Claude is playing a very active role in designing the next Claude. We can't yet fully close the loop, but there's a positive feedback loop. We haven't created a positive feedback loop entirely yet. It's not going super fast, but it's definitely started. This is pointing directly at the takeoff idea that was mentioned by Rune in that earlier tweet, and that is one of the culminating points of the AGI and superintelligence ideology. If we're able to create AI that can proceed with its own AI research, it can create a more powerful system, which trains itself, which creates and obfuscates no longer have the need for humans to be part of this overall cycle. And so we're not there yet, but it's the explicit goal of a company like Anthropic right now to build this. So, are these technical barriers too difficult? There's also a question of are they sufficient? We really don't know if automating all of these different pieces will create systems that, go hypercritical in the way that many have talked about before. But what we're looking at here is a thesis, which we might call the functionalist thesis. People sometimes use the word computational functionalism. I'm calling it AI functionalism. But the general question here is we know that humans can do things that AI systems can't. For all of those skills that humans can do, can we automate them? Can we clone them with AI? Can we stitch those parts together? And having done that, what does that get us? Does it get us AGI? Does it get us superintelligence? Does it get us the takeoff? That's a really important question. And many of the people within the tech space hold this view of AI functionalism that says, yes, we can automate all of those parts of intelligence, and that's what we're trying to do. And should we be able to create the technology that does that, it'll go wild and maybe change the future in some highly significant ways. Given that I'm speaking to AI and faith, I want to mention some common counter arguments to this, which is, does AI have wisdom, a soul, embodiment, consciousness, love, will? I'm just going to address a few of these really quickly because I think they're very common objections to this point of AI functionalism. My personal view is that probably AI can automate intelligence. All of these logical, rational steps, that's exactly what AI is built for. But maybe it won't be able to automate wisdom. The why, the are we doing this for a good reason? The problem is that that doesn't really throw away the claim of AI functionalism. What that suggests is that we might be able to get very, very powerful systems that are unwise or not wholesome or unkind in some meaningful way. And so to me, that's not an argument against the possibility of superintelligence, but it is an argument against the safety of those systems. I underscore love here because I think there's something very deep in this feeling of maybe there's something wrong with that whole functionalist point of view. I know a lot of people that are allergic to this, and they're allergic to it because they know that there's a profound difference between simulating and emulating something and the real version of it. You can have a great AI caretaker, maybe, but you can't have an AI mother. The connection between a mother and her child is not the kind of thing that is just in the actions. It's in the spiritual decision to give birth and create a life in the first place. Those types of relationships, those types of human functions can never be automated. And as far as Buddhism is concerned, which is sort of the group that I'm representing, there's a massive category of inner work and a personal dimension of things that AI can never automate. The problem is those things are not really just the intelligent capabilities part. And so it's very possible that we get systems that do get really, really powerful and are missing all of these core things that are important to us as humans. The last one I mentioned is will. And on this one, I think AI can do something like this. It's not the same kind of human will, but what we see with this increased automation, the ability of AI to act over longer and longer time horizons, is that it gets less clear where the original decision-making authority comes from. If I ask one question and then the AI operates for 8 hours and spawns a whole bunch of other actions, and those actions maybe inspire someone else to do something, whose will was it in the first place? And so to me, the question of will is a bit complicated and becomes maybe better to look at through the point of task horizon, how long the AI can operate without requiring human oversight. And if at some point it can operate without any human oversight, I think we've crossed some sort of boundary around will. Okay, what does this all mean? Well, in the history section, we talked about the AGI ideology as being real, having a history, and informing some of these technical efforts. Here, we've looked and seen that LLMs are very powerful. They can surpass experts, and there's a reason why. You're sort of pulling out this potential possibility from all of language space. We're getting closer to automated agents. People are working on that actively. And that there's a build path towards these more powerful and agentic systems that people are pursuing quite quickly. Functionalism as a hypothesis is the key thing to keep in mind here, because the argument against functionalism is either somehow that frame is wrong, or hey, here's a thing that cannot be automated that is somehow really important for future capabilities. If you can say that, well, then you found the barrier. You found the thing that blocks this possibility to come into place. But right now, Silicon Valley is betting on this being possible, which takes us to safety. Lots of safety depends on how powerful you think this technology will become. Right now, we know there's problems with AI. There's been a lot more conversation around AI psychosis, hallucinations, and job displacement is hugely on the horizon. There's also been conversations about misuse, AI weapons, deepfakes, and potentially in the future breakdowns in democracy, mass manipulation. One thing that's highly confusing is what about accidental risks? If we just create really, really powerful AI technology, what just like happens to society in general? A lot of people's views on this are dependent on the scope of how powerful they think AI will become. So here's a little flow chart. Does not totally cover all the categories, but to me, it helps shape some of the main views around AI. Um, if you think AI will be similar to today, we've hit a wall, the bubble's about to burst, you're looking at today's issues, which are still bad and societally quite relevant. Maybe you think it's going to be more powerful, but not transformative. We're looking kind of at the same thing. Power concentration becomes a huge issue, certainly environmental degradation, significant ways that AI exacerbates many of the global problems today. But the reason I highlight these both yellow is because they're categorically very much set within the terms of how issues in the world look now. When we start to look at AGI and superintelligence, things change. If you think that this kind of technology is extremely powerful and that it's controllable, then you want it on your side because you want to win. This is not all humans, but this is what happens when you take powerful technology and you think about it within the realpolitik frame with which global operations are happening now. If you think that this powerful technology is uncontrollable, you start to end up in the world of existential risk, which is to say, nobody can control this. Things go wrong for all of us if we build it. And then AI becomes one of the most important issues because it is so defining for how the rest of the future will go. We don't know the answers to these questions. But what we do know is that there's people who believe different things across the spectrum, and many of those people are taking actions that are shaping the safety and the technical landscape now. So this chart here is from a conference in Silicon Valley just a week ago called The Curve. Here's what they're talking about. The space of possible futures explodes. There's different combinations of capabilities that have large implications for the future. Agile adoption will matter. Don't hold your breath for drop-in remote workers. We need more arguments between AI believers, in this case, the people that believe in this crazy technology, and the grizzled doing stuff as hard veterans. Centaurs may persist. This is humans and AI working in combination. Maybe that'll last for a while. Finally, the timeline too crazy. This is very in-group. This is niche upon niche. These are people who believe in this view and are holding conferences to talk about it. But I'm putting it up to show the reality of this is the conversation they're having. They're really having the conversation. Which world are we in? And what does that imply for how the future is going to develop? So let's say you care about today's issues, power concentration, but also the harms that are happening right now. For example, I imagine many of you have seen this story, which is about a teenager who committed suicide after talking to ChatGPT, and his parents are now suing OpenAI. This is a huge problem. AI psychosis is growing, and the number of people who are forming relationships with AI is growing very, very rapidly. The deeper thing here is that our relationship to truth is starting to become manipulated as well. And so earlier this week, OpenAI put out a new model, Sora, which allows people to create videos very, very quickly. This is a video of Michael Jackson and Tupac, who have now passed away a long time ago, having a conversation.
It's crazy how quiet it gets back here. You wouldn't think this is the same city once the lights go out.
Yeah, man. Out here, you can actually hear yourself think. Kind of nice for a change.
I like it. Gives you space to dream a little.
You always dream.
It's the only way I.
So things are getting complicated because there's a lot of people, elderly and children, who will fall for this kind of stuff. And what it means for all of the rest of us is that archival footage is not super trustworthy anymore either. And so these are really huge questions that are happening today. And yet, they're also pointing at a much broader pattern where AI is really changing the stakes of what is safe and what is not safe for us. So what are people doing technically? We can return to the slide and go through some of these details if people are curious, But the main thing that I'm trying to show here is that we can apply safety strategies to the models themselves, trying to get those base models safer or the post-training to make them more ethical, to applications, which is, okay, the models are what they are, but we want our product and our end users to see something important. Or we can say, screw that, we're going to have a human oversee it at the end of the day, or we're going to have a filter that just blocks out certain answers. These technical approaches are really patching minor problems. They're not addressing the societal risks that we see from this technology. None of these things help us shape what is true, what is not true, how do we distinguish between the two. And so we go to regulation, which is that on many different fronts, you have international, you've got national regulation, you have economists that are looking at job loss, you've got people who are looking at the dangers of AI in schools, and you have national AI safety institutes that are popping up to address this stuff. Lots of people are focused on these present day issues and are taking actions to make this all safer through various regulatory means. However, this is not the strategy that you would take if you think that AI is necessary to win some sort of global competition. There, you'd see something that looks more like this, which is the national policy that the US has around AI. As we looked before at the AI action plan, the first sentence was that we have to win this global race. And you can see this in a lot of the compute control stuff, which I'll go more into in a second. But here is a particularly telling line from Dario Amodei, who runs Anthropic. He says, there's a great question of AI-powered authoritarianism, which seems too terrible to contemplate. And so democracies need to be able to set the terms. He imagines a coalition of the willing and an entente strategy, where he says the coalition would on one hand use AI to achieve robust military superiority, and on the other hand, the carrot, distribute the benefits of AI to a wider group of countries in exchange for supporting the coalition. This is very, very polite and very political language, where the implication underneath this is we were going to create powerful AI weapons that are so powerful that the other side won't be able to compete. Or we will be able to dominate the economy so much that there is no global competition from authoritarianism. This is a profound view that's being stated here, and it's deeply embedded within the national strategies of major countries. Recently, a researcher left Anthropic, the company I just quoted from, over its anti-China stance. Not a huge surprise. Today, there's been an escalation from China where it's announced export controls over rare earth minerals, and so they're fighting back. Dean Ball, who's a big commentator on AI, says this is a big deal. China is taking a step up, and this aggressive policy could lead to a huge economic recession. So this is the current geopolitical competition that is happening between the US and China over AI, and it's really built around the story of AI becoming transformatively powerful. There's still another safety view, which is, let's say we have AI that is so powerful that it's not the kind of thing that any country could oversee on its own. Here we end up in the territory of the canonical definition of AI alignment, which is about creating powerful systems that are more powerful than humans and are aligned to what we care about. And the reason the term alignment is important here is because we're talking about things that we no longer control. And so they have to just be keeping our best interests in mind as they operate at scopes of agency beyond what we know. The central quote here is from OpenAI. It's from a 2023 strategy they put out called Super Alignment, where they say, we're going to build a roughly human-level automated alignment researcher. We can then use vast amounts of compute to scale our efforts and iteratively align superintelligence. What this means is, hey, we're going to make AI that's more powerful than any human could ever oversee, and so we need to train an AI system to watch over that and keep it safe. System 1 can make System 2 safe, which makes System 3 safe, and so on. This sounds pretty crazy, but it's the central safety strategy of these large labs because they think they're training a country of genius in a data center. And to keep that kind of thing safe, no human can oversee that. This is where we get statements like cases mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks such as pandemics and nuclear war. This is roughly why. We're creating technology so powerful, no one will be able to control it, and it's going to wreak havoc in many mysterious ways. The reason I mentioned the AI alignment forum down here is because this really is not hype. There's people who are talking about this who are not part of the labs, who are just concerned from the same ideological perspective that that history traced and are writing about it every day through articles like this. Plan A. We need some sort of international agreement that eliminates race dynamics. Plan B. The US government agrees to buying lead time. So on and so forth. This is a post from today. If you look on the right-hand side, these are the other posts. Notes on fatalities from AI takeover. Inoculation prompting. The rise of parasitic AI. I'm just pointing to this to show the real examples of people who are thinking about this as part of their day job and creating communities to talk about it. This is a broader map of the folks that are concerned with existential safety. It's a lot of orgs. It includes many of the major labs. Happy to link to this later if people want details on it, but again, not just me and some of the other crazies. So what? Well, we talked before about how people make plans based on the world they think they're living in. Ideology informs action. And in this case, the people with the most resources are shaping the world based on their AI ideology, where many of these people believe in these stories of geopolitical domination or existential risk. Those approaches about building extremely powerful AI are driving the lab's behaviors. To me, this looks like soteriology, which is to say that we're imagining futures that are so powerful that AI is the primary driver of them, and that the implications shape the future of humanity. Soteriology is about doctrines of salvation. This is something that religions have a lot of familiarity with. And so what we're seeing is a tech-based soteriology, the rise of this worldview that says AI is so powerful, it holds all the future stakes. We should put all of our eggs in this basket, and we need to win. And that's a lot of the energy that's driving the AI movement today. We talked about where the ideology comes from. We talked about the functionalist perspective about why people are taking this seriously technically. And we talked about safety concerns, how different applications of what to do come based on your ideology. And ultimately, how the AI alignment view comes from the perspective that humans are not going to be able to control this future, that ultimately it will be in the hands of AI, and we need AI systems that know what we want them to know and either stay within our bounds or are able to act on behalf of us because they're so powerful that we need other AI systems to watch over them. This has spiritual stakes. Soteriology is inherently spiritual. And so I think it's extremely important for a network like AI and Faith to take a question of superintelligence seriously. Not because you need to buy all the technical arguments, but because the ideological history here and the human motivations behind this are really in the professional hands of moral authorities and religious experts. This is a domain that religious experts understand better than others, and where we need to start thinking about what a positive future looks like that's really different from the one that's implied by all of these strategies. So this is a hard point in the talk because I think for some people, it's like, you're crazy. I don't worry about this kind of stuff. For others, it's like, okay, yeah, I already get it. I'm already working on my stuff. I know how to handle this. But for some people, it's like, whoa, is that really what's going on? This can be an emotional juncture. This can be a stressful juncture. I recently heard a talk from the Center for Humane Technology to a number of Buddhists, where some people wrote in the comments that they were feeling very disturbed after hearing his talk. And I think it's at this point in the conversation where our humanity becomes most relevant, and again, where religions and spiritual professions have a lot to say. This is crazy. The reason that so many people are buying into this is because it's a psychologically powerful thought. It's scary and it's addictive. And as more and more people start to become disturbed by the pace at which AI progress is changing, what they're really feeling is the psychological edge of this worldview starting to bump into them. They're feeling the feeling of people trying to shape the world based on ideology and its results and its discomfort. And so spiritual caretaking is important for ourselves and for others, and is one of the huge roles that I think religions can play in this time when many people are becoming ungrounded at the pace of technological change. This is also the place where, after grounding ourselves, we need to think about, so what do we actually do about this? Like, how is it even possible to respond to this kind of situation? I think first, it requires thinking about a positive future, which is that I've talked a lot of negative things here. And of course, there are many positive uses for AI, But it's not just about how AI can be used positively. It's about what world do we want to build? What does peacemaking look like? What does a better democracy look like? How do we shape society? These are the kinds of questions that are coming to people's minds now as AI gets so powerful, because it does feel like the stakes are on the table for making large decisions. It feels like things are really unpredictable and can go in a lot of directions. And so this becomes a critical time to define a better path. If the default path is just building more and more powerful tech and letting the current ideological forces sort things out, that doesn't look like a good future. And it's very hard to respond reactively to that. And so what's better is creating a positive future that we can be proactive towards. And this requires moral grounding, this requires clarity, this requires wisdom, this requires heart, and it requires multi-faith collaboration to say, what is a better alternative to this? Buddhists are doing a few things. Buddhists are thinking about how AI can speed up Buddhism. That's knowledge infrastructure. They're thinking about this question of AI alignment and if Buddhist wisdom has something to contribute to it. They're thinking about the conversational frontiers on scholarship, philosophy, and science. They're teaching. They're doing spiritual caretaking. They're getting involved in governments. And there's organizations like mine, which is working on ecosystem and capacity building. We're helping support everyone who's currently working in many different parts of this field. But ultimately, is that enough? What is that really pointing towards? We're in a complicated situation where there's many competing ideologies right now, and none of them really have obviously good outcomes. AI domination, not a good outcome. We don't want one country to win over another. We want to create diverse, pluralist communities that can last for a long time. We don't want existential risk. And so is the answer to not build extremely powerful technology? Well, then you need to do a bunch of regulation, and it doesn't really seem like we're on track for that type of slowing things down. Maybe it just won't become that powerful. Can the Buddhists help shape this? Here's where the conversation is at. There's a lot of questions. Where my organization is sitting, it's not clear which is the best path. It's not clear which is the avenue that can help get to a good future. And our best strategy right now is taking one step forward at a time, really starting to communicate and collaborate with other people in the field about, okay, where do we want this to go? And building a shared epistemology, which is to say, do you think that this is what they're thinking? Is this really what the shape of this problem looks like? Because if we can come to a consensus on which world we're living in, then we can start to come to more of a consensus on our strategy and overall where we're going. And I think it's very important that religions take this seriously now. Whether or not you believe in some of the technical things I talked about, or even if you think that AI is going to become this powerful, this is a time where regular people really need help to stabilize as the world gets crazier. That's the role for religions. And it's also a time when moral authority can speak out about ideology and say, hey, that thing over there is a soteriology, and it's not leading where you think it should lead. And so I do think there's a really powerful role for religions to play right now in various spiritual communities in the AI conversation. And yeah, my hope is that my organization can do this and everyone on this call can be inspired to think at a similarly broad level about the implications of everything that we're doing here today. So to conclude, we talked about the history and the AGI ideology and where it came from. We talked about this functionalist perspective. We talked about how AI alignment and other safety strategies are required for more powerful technology. And finally, we've talked about the spiritual response to the AI zeitgeist, which is something that I think is super critical for today. And so I thank you all for listening. That's the presentation. I'm happy to answer any questions, and hopefully this made sense.